Let's learn how to get data in and look at it. We'll need to remember a few things about Pandas first. Pandas is a library for data analysis. The power tool of Pandas is the data frame, a tabular data structure with labeled rows and columns. As an example, we'll use a data frame with Apple stock data. The rows are labeled by a special data structure called an index. We'll learn more about indexes later. Indexes in Pandas are tabled lists of labels that permit fast lookup and some powerful relational operations. The index labels in the Apple data frame are dates in reverse chronological order. Labeled rows and columns improve the clarity and intuition of many data analysis tasks. When we ask for the type of the object Apple, it's a data frame. When we ask for its shape, it has 8,514 rows and 6 columns. The data frame columns attribute gives the names of its columns: open, high, low, close, volume, and adjusted close. Notice the apple.columns attribute is also a Pandas index. Actually, the apple.index attribute in this case is a special kind of index called a datetime index. We'll study datetime indexes and time series later. Data frames can be sliced like NumPy arrays or Python lists using colons to specify the start, end, and the stride of a slice. First, we can slice from the start of the data frame to the 5th row, non-inclusive, using the .iloc accessor to express the slice positionally. Second, we can slice from the 5th last row to the end of the data frame using a negative index. Remember, it's also possible to slice using labels with the .loc accessor. There's another way to see just the top rows of the data frame, the head method. Specifying head 5 returns the first 5 rows. Specifying head 2 returns just the first 2 rows. The head method is particularly useful because our data frame here has over 8,000 rows. The opposite of head is tail. Specifying tail without an argument returns the last 5 rows by default. Specifying tail 3 returns the last 3 rows. Again, tail gives a useful summary of large data frames. Another useful summary method is info. Info returns other useful summary information, including the kind of index, the column labels, the number of rows and columns, and the data type of each column. Pandas data frame slices also support broadcasting. We'll learn more about this later. Here, a slice is assigned a scalar value, in this case nan, or not a number. The slice consists of every third row starting from 0 in the last column. We can see head 6 to see the changes. We can also call info and notice the last column has fewer non-null entries than the others due to our assigning nan to every third element. The columns of a data frame themselves are a specialized data structure called a series. Extracting a single column from a data frame returns a series. Notice the series extracted has its own head method and inherits its name attribute from the data frame column. To extract the numerical entries from the series, use the values attribute. The data in the series actually form a NumPy array, which is what the values attribute actually yields. A Pandas series, then, is a one-dimensional labeled NumPy array, and a data frame is a two-dimensional labeled array whose columns are series. We've seen a few concepts extending what we already knew, including head, tail, info, index, values, and series. Take some time to practice using these concepts in the exercises.